In this video, I'll show you how assigning objects to variable names can be useful. Let's start from this program already in progress. You see I've created two different spheres in an arrow. Since I want to reference the attributes of each sphere separately, I'll call the first sphere Sue and the second sphere Bob. What we're really doing is assigning all the attributes of each sphere to a variable name. Here, by calling the first sphere Sue, all of the information about the sphere is stored in the variable Sue, including its position, its radius, and its color. This can be very useful, say, if you want the tail of the arrow to begin at Sue's location. To reference any of Sue's attributes, simply specify the name of the attribute after the name of the object. Sue.pos represents the vector position of Sue. Sue.radius represents Sue's radius and is a simple integer. Okay, so back to the arrow. If I want the arrow's position to be the same as Sue's position, I can simply replace the arrow's position vector with Sue.pos. Now, I'm in a position where I can easily create a relative position vector pointing from Sue to Bob. Be careful here, as we must remember what the axis attribute does. The axis attribute is defined by the x, y, and z components of the vector that define the length and the direction of the arrow. If we want the arrow to reach Bob's position from Sue's position, would simply typing bob.pos work? Running the program shows that although the arrow starts at Sue's position, it does not point towards Bob's position. Relative position vectors are defined by taking the location of where you want the arrow to end and subtracting the arrow's beginning location. In terms of our spheres, this would be bob.pos minus Sue.pos. Running the program shows that we now have an arrow representing the relative position of Bob with respect to Sue. In this example, the calculation for the relative position vector for our axis attribute is the same as what you would do on paper for a homework problem. In physics class, we like to use arrows to represent different types of vector quantities, like force vectors or electric field vectors. The axis attribute essentially defines which type of arrow we are using in the program. Only when the axis calculates the final position minus initial position does the arrow represent a relative position vector. Likewise, we can make the arrow represent other vector quantities. All we need to do is change the axis attribute to match the values for those desired calculations. Your challenge is to connect the three spheres shown here with arrows to create a counterclockwise path. Do this by using references to named 3D objects, as discussed in this video.